Hello, everybody. We are going to get started with our webinar shortly. We're just going to give a little bit of time for everybody to arrive, but we're happy to have you all here. Hello, everybody. We will give it one more minute for everybody to join, but we're happy to have you all here. All right, let's go ahead and get started. Hello, everyone. My name is Mario Munoz. I'm the Outreach and of Education Chair for the Women in Mining Arizona chapter. We'd like to say welcome and thank you for joining us today on our talk on chemical crushing and mining. Before we get started, we want to give a brief introduction to our organization and why we're hosting these talks, if it's your first time joining. So the Women in Mining Arizona chapter, or WIM-AZ, is a nonprofit organization with 5 objectives, one of which is to educate our members and the public on technology, economic, regulatory, and other mining-related topics. These monthly dig-in webinars are a part of our efforts to meet this commitment. We also have 2 special announcements today. First, the WIM Arizona chapter is hosting the Women in Mining National Conference this April 12th through the 15th. It will be held here at the in Tucson Convention Center. The conference includes a volunteer outreach day, a jam-packed conference day with roundtable discussions, networking, panels, and a professional development workshop, as well as field trips. So it's going to be a great experience, and we encourage everybody to join. You can scan the QR code here, or we can provide a link in the chat in a bit so that you can learn more about the conference. We'd also like to invite members to come volunteer with our education and outreach team. If you are looking to get involved in outreach and give back to our communities, then there's several events this spring semester that we can all get involved in. Our next events are on March 4th and 5th at the Tucson Festival of Books. We also have some on March 11th at the Southern Arizona Research Science and Engineering Foundation STEM Expo. April 12th for the Girls Experience Mining Day hosted by Caterpillar, and April 19th for the Mining Day at the Arizona Capitol. We provide orientation and outreach materials for all volunteers, and no experience is required. We encourage each person to give their own personal touch while meeting face-to-face with our communities. Now back to our main event today, we'd like to give a brief thank you to WIM Arizona Platinum sponsor Freeport-McMoRan. So now I'll turn it over to Alexia, who will introduce our speaker.
Hello, everybody. My name is Alexia Navarro, and I'm the corresponding secretary of the Women in Mining Arizona chapter. And I'm going to be introducing our speaker. Patricia Lim works with the Electronic Cells Group, providing technical support with electronic initiations. She has been with Dyno Nobel for 11 years. Previously, she was a formulation chemist for explosives research with a company called ICI Explosives, currently Orica, located in McMasterville, Quebec. She has also worked as a formulation chemist at ETI Explosives, Field Applications for ACE Explosives, Federal Explosives Inspector, Explosives and Radiation Compliance for Weatherford before taking on her role with Dyno Nobel. So now you can take it, Patricia.
Hello, everyone. Can you hear me?
Yes.
Okay. Thank you for the invitation. I am extremely honored. Women in mining have been there. I guess ultimately it's been a long journey for women to get into the mining industry. When I started about 30 years ago, going underground was extremely difficult. And now times have changed, and it's very, being a woman going underground is very welcoming. We come off as non-hostile people. So suggestions are more easily made to miners. And I guess it's just a different approach. I'm here to speak to you today about chemical crushing, and ultimately with the use of explosives. I always feel like we need to, when we're in the blasting world, but not only chemical crushing is important, but also both physical crushing is important, so that it saves the mining company more money downstream in terms of hauling, crushing, just totally end user, how we can save money. So I just want to go through a quick presentation. Feel free to interrupt me at any point in time should you have any questions. Unfortunately, I won't be able to play any of the videos that I prepared for the presentation, but we can just go through it and talk about it. Right. So if I may share my screen. Okay, chemical crushing, how can we achieve it? Today, I'm just going to focus on underground blasting, just in development headings. We can do another one on quarry and construction or open pit mining or whatever other topics anybody that wants to cover. But today, it's going to be about chemical crushing underground in development headings. So typically, how do we achieve this? Well, I can't scroll down.
Try the arrow.
I tried. There we go. Thank you. So how can we achieve this? Well, we can achieve it with using proper timing. Timing is extremely important for underground development headings. We also have to look at product limitations. If your holes are wet or if the holes are dry. Proper loading practices, that's absolutely critical. And our insight, what's our previous experience with respect to rock geology. So in a development heading, what happens if a round is improperly timed? You can have the round freezing, so therefore the rock won't break. You have poor fragmentations. You end up, instead of having fragmentation the size of cell phones, you have the size of Volkswagens, for example. You have bootlegs that can occur, or you can have backbreak in the ribs and jaw, and in the ribs and the crown. All this results in mining inefficiency. So when you have mining inefficiency, then you, for example, if you have a round freezing, how do you fix it, for example? If you have poor fragmentation, how does the scoop put the ore into your into the hull trucks? If you have column shifting, what happens? You end up with a lot of explosives in the muck pile. All these things are very detrimental to the mining industry, right? Or to that heading that you are trying to advance. So these are just a couple of examples. So this is a typical blast design for underground headings. So you see in the center, you have these 5 little holes, and that's called the cut. So what you want to do is essentially, if you're using non-L timing, you're using non-L timing, and you start with the smaller numbers, and then you work yourself up. So essentially, when you're trying to shoot a development heading, you're using a diamond square, and expand out, so that all the rock goes from outside to inside. I'm sorry, it's from inside to outside. I'm sorry about that. So what you want to do is you want to increase as much void space as you can so that you can have all your rock coming out, right? If you use your larger numbers first and your smaller numbers in the back and in the ribs, that would be absolutely detrimental, because then you're not going to get the fragmentation that you would like to achieve. This was a mine where it's actually quite funny, and it's unfortunately I'm not able to play the video, where this round was improperly timed. And instead of using sequential delays on it, I believe they just used one single delay, and you had the whole portal, that's what they were trying to shoot, they all come out at once. It took out compressors, it took out a lot of the equipment that it took out the portal heading, and they had to relocate the portal heading, which probably cost a lot of money, as well as it delayed the beginnings of the underground development tunnels. In terms of products, we have to know what our product limitations are. For example, you cannot use ANFO in wet hose because ANFO has no water resistance. If you use ANFO in wet hose with no water resistance, you are not going to get any product initiating. You'll just probably get the booster and your shock tube or your detonator initiating, but nothing else. So therefore, you will get no fragmented rock. The minimum diameter, if it's a dry hole, needs to be respected. If the holes are too small, you will not meet the critical diameter. And when not meeting the critical diameter, your product is not going to shoot. It's not going to shoot well. And then therefore, if it doesn't shoot well, then you'll probably get a lot of large fragmentation. So the important thing is to know your explosives limitations, what it can and what it cannot do. So this is an example of a booster sensitive explosives. This is ANFO or Dynamix. It's made with 94% AN, ammonium nitrate, and 6% water. If you look at the properties, this is what it's supposed to shoot at. If you don't meet the criteria and if you don't respect the explosives properties and you try to cut corners, you will not get the fragmentation as required. And therefore, when you don't have that, essentially, when anything from drill to mill, it's going to increase your costs. This is an example of an explosives using ANFO, not respecting the critical diameter, using smaller holes and not using it properly. You get velocities like this. In this case, I probed 5 holes for speed for VODs, and these velocities were all over the place. So, and it didn't even meet steady state velocity. So steady state velocity is about, I don't know, I think it's like 3,600 meters per second. And in this case, it's some shot at 250 meters per second, 1,000 meters per second. It did not function as well. And it was just essentially becomes a waste of explosives. This is what happens when you end up with using explosives improperly, smaller diameter, holes drilled at smaller diameter, or if your explosives is used in wet applications when it's supposed to be in dry application, this is the type of fragmentation you get. Loading practices. This is absolutely critical. Explosives, emulsion explosives do not have any gap sensitivity. Unlike nitroglycerin-based explosives. Nitroglycerin-based explosives actually propagate, and it can actually jump almost about 2 feet, shooting from if you have a gap of 2 feet of nitroglycerin explosives, it'll actually jump and propagate. Emulsion explosives made with ammonium nitrate does not propagate. They have to be touching. In order for the explosives to properly initiate, you have to have proper placement of your primary assembly. Your primary assembly is your detonator as well as your booster. If you place it in an improper location, like for example, at the very bottom toe of the hole, you may have foreign material encapsulated around it, not being able to touch your emulsion explosives and therefore not propagating fully. This is was a video that I was going to show you that what happens if you load the explosives, but you have gaps in it. If you have gaps into it, it will not shoot. That's another video. Unfortunately, I wasn't able to put it in. So ultimately, underground course, Dyno Nobel does provide intro to open pit, advanced open pit courses that that we can cater to your needs. We would be happy to do some for other courses that you may have, or any questions that anyone in Women in Mining may have. And we can talk more in detail about some of these very basic issues. Thank you.
Thank you, Pat. Does anybody have any questions? If you feel free to put them in the chat, and we can have Patricia answer them for you.
Yeah, there was a question about from Daniel on how much savings do you suggest? How much savings do your suggestions get you?
The first thing we do is we come in and do an audit to see what is being done right and what needs improvement. Savings if you're using your explosives properly, you can save quite a bit. Now, I mean, that's pretty well a loaded question in terms of a numerical value. I cannot tell you right now, but it's so in order to give you a value, we need to just do an overall audit to see what we would look at product use, if you're using the product correctly, if you're using the right product for your application. Are you using too much an expensive explosives that's not suitable for your needs? Then we look at downstream. If we look at your haul trucks, how much maintenance are you currently using, or that's currently needed? What is the fragmentation of the rock? What is your desired fragmentation of the rock? It depends on a whole plethora of things.
Are there differences in timing or pattern if it's underground?
Oh, yes, there is. Well, depending on how big your heading is and how you want to time it. You can also use, I mean, right now, a lot of mines are going to electronic initiations, and electronic initiations, you are not limited on your standard LP long period timing. So yes, there are different. If you're looking at the development heading, there are certain timings that there are standard CAN timing, but you can always try out what works better for that rock geology.
Is it good for hard and soft rock?
What is good for hard and soft rock?
Can you expand on that, Daniel? Your system, is it good for hard and soft rock?
There are, so Dyno Nobel, we have different systems. We have electronic systems. And we also have standard non-L pyrotechnic systems. With pyrotechnics, you're kind of a little bit more limited in terms of electronic initiations. With electronics, you can actually time what you want. So with LP timing, you have, like, say, for example, your LP1 could be 500 milliseconds, your LP2 could be 1,000 milliseconds or 800 milliseconds. With electronic timing, you can set it to 300 milliseconds as whatever timing you want it to be. So that's one thing. The other thing is the amount of explosives that you use in your hole and what kind of explosives you want to use in your hole. Nitroglycerin-based stick powder will shoot hard and shoot fast, but it may not give you the fragmentation you want. If you use ANFO, it'll give you the heave that you want, but you're limited to the amount of you're limited to the wetness of the hole. If the hole is dry and you're pneumatically loading it at 1 7/8 inch diameter, which is fairly standard, you'll get good heave and fragmentation. However, the holes need to be dry. If, for example, you're using an emulsion-based explosive, you can vary the density, and then you can make it the density of the explosives thick, higher or lower. But we need to be careful, because then we need to ensure that we are not exceeding the maximum density allowable to shoot for that whole diameter.
For sure. And then Camille asked, what are some general recommendations on blasting agent choice for underground versus open pit mines? Besides wet and dry consideration, understand much more detail is needed to make a determination for specific applications.
So, so typically the biggest difference for underground and the use of underground explosives and surface explosives or open pit is your hole diameter is a lot bigger. So when your hole diameter is a lot bigger, it's a lot more forgiving. Underground mining is a lot more difficult because of the hole size is small. So in terms of if you're looking at cost for bulk explosives is cheaper. However, you're using a lot more of it. Does that make sense? Yeah.
Certainly. And then Tiffany asked, how can you tell if the holes are wet or dry? What if it's dry on the top but wet underneath?
Oh, so that's a very good question. So what you do typically is you can just drop a rock down, and if you hear water, then you know the hole's wet, right? Now, having said that, you know, I ask people whenever I go to a mine site, I always say, so what product are you using? And if they're using ANFO, and I've mentioned numerous times that ANFO is made for dry holes only. So everybody says, oh, it's only good for dry holes, which is fine. You go to the pattern, you go to an open pit mine and there's a foot of water in there. So then they say, oh, just loaded with ANFO, it's fairly dry. You just told me that before we went on the bench, it was ANFO is only used in dry holes. What changed from being in the office telling me that and going on the bench? When people need